Hi, dear students. Welcome to our web summarizer, a Python Jupyter Lab program for the web mining. My name is Dr. Himat Alisha, and agenda of this Python project is to find number of tags in a web page. We will discuss six important topics. So, second number thing, we will find top 10 most frequent tags from a web page. So, we'll figure out which tags are most frequent by number. Third thing we will find for analysis purpose, depth or root of the tags. So, a root is basically a body tag. So, we will find each tag's depth, nodes, and leaves. Then we will link inside the page. We will try to find how many links available inside the web page. So using those tags, top frequent, we will also analyze using matplotlib. Then we will convert those links which we find inside the web page into absolute path links. Basically, they are relative links and available in the web page. We will convert them to the absolute path links. And finally, we will find very important information for the web page: title, meta description, robot tag, canonical URL, and counts the open graph and Twitter card tags, like using beautiful soup library. So please keep watching.
So let's start the program. So we need to import two packages. Import urllib.request to fetch through URL of the web page, and we need beautiful soup to make navigation of that web page and make it beautiful from the structure of CSS, JavaScript, and HTML. So let's begin. We can say URL equals to, you can input URL in any of URL, HTTP. For example, we can say bbc.com. Further, you can change the URL, depends. So you can say request equals to dot request. We need to request URL and need address. User/agent, and we need magic browser. Then we need to open that request. So we can say URL lib dot request dot URL open, and we call this as request. Let's check. Yeah, it's working. Let's read this request in as HTML now. So we can say HTML equals to not as request. We can this is on now. We can say HTML equals to con dot read. So we can check HTML now. So we can see clear HTML, messy HTML with CSS structure and JavaScript inside. Let's run the code again. So now we need to use beautiful soup. this one to make it beautiful. So we can say soup variable equals to beautiful soup, and we need to pass this HTML and parser, HTML dot parser. So let's check now difference between HTML and soup. Soup makes it little bit prettier, but we can make it more prettier by saying prettify. Soup.prettify makes it beautiful and prettify code. Okay. So we got soup now. Let's play with the soup. Soup dot title, we can say we will have a title for the web page, which is HTML, BBC Home, breaking news, world news, so on. And then we can say dot string, makes it a string without HTML text. Maybe we can also use text. Yeah, makes it text and a string, both of them. Further, we can say, for example, soup dot find underscore all. Then we can have this, for example, we want to find h1. Yeah, okay. And then we can say if we want to find multiple text inside. H1, H4, H3, H2, H1. Yeah. So let's run this soup.find. We can say we can loop through these for headings in soup.find all. We can say same, and then we can print headings. Still headings cell headings dot gate underscore text and strip equals to makes blank spaces separately so that reduce that one. Okay, so maybe double quotation. Yeah, now you can see better, prettier code. And we can separate, for example, print. Make it in a better way, so the separation makes visible. So now we can see. Now let's check. Let's make this soup and define find all soup. Make this function. So it takes soup and make it better. Okay, so now we check also links maybe. So we can say soup.find Let's go all. We need to find anchor tag and href equals to true. And we need to go through the loop again for h in, maybe we can say for link in, need to print this one. We can say link and href. So we can see links inside. There are multiple links available in the same page. So you can demonstrate, analyze the links using web page. Now we can have a soup and URL. Now next target is to find number of tags, total number of tags in a web page. And then we need to find also top 10 most frequent tags from the web page. So what we will do, we will also analyze the data set, and we will find out number of tags inside each web page, and we then analyze the impact of tags and what are the most frequent tags used in those web pages. So let's continue from here. So first thing we need to import from collection, we need to import counters. So because we need to count them, so it's important that we need to import counter. We need, we call it tag names as a variable, and before starting this, first we check soup dot find underscore all. If we make it as a true, what happens? So you can see all the tags, data and text comes here. So we can say from here tag names equals to, we need to find all those tags from this soup dot find all. So we can say t is a tag name, t dot name. We can say we need to convert this as a lower, because all tags need to be a lower dot split function, split them from the colon, because data is separated from this colon after the tag, to -1 last part of the text for t in soup dot find all equals to true. Let's check tag underscore names. Yeah, you can see all those tags. So we have HTML, head, meta, all those tags available in the form of. So let's count the length of the total. We can total tags equals to length tag underscore names. First, we need to print the type of tag underscore names. It's a list. So make sure that this length function applies on only list. So we can say total text. So we have around 2234 different tags, total tags. too many. So we need to find unique tag underscore set equals to set. First, we need to make as a tag underscore. So underscore names. So we can say unique underscore tag set. So we need to count them. So we can say count length form count unique tag. This one count. So we have 32 unique tags used in the BBC web page. Let's check what are the most frequent tags used for. So for that we need counter function. So we can say top 10 equals to counter tag names dot most underscore common. We can say 10 and we print top 10. So we have div use over 1,000 and anchor use 230 times, path use 119, h2 116, link li 114, image use 108, span use 89, ul. So these are the top 10 text. Maybe we need top 5 only. So div, anchor, and h2. We can say top 5. Okay. So next question, number of tags we found and number of total most frequent 10 tags we already had a result. So we print it in a better way. Let's see the summary, what we got it. So we got total tags 2234, unique tags we had 32, top frequent 5 tags, div, anchor, path, h2, and li. So this is the answer to these questions, find number of tags and everything. Okay, so now we converted this into the function find number of tags, and soup is a parameter. So we just call this function here and it runs. Now next target is to find appearance of each unique tag. How many times a particular tag appears? We have 32 unique tags, we know this. So for that we need this tag name and counter function only. So we need this one and we need to count. We can say counts equals to counter tag names. Let's check counts. So we have this dictionary. So now what we need to do is print this one and print is a table. We need two prints. For that we need need this sign to separate it, and we need multiply 26. So we need F here and this one. This needs to be a tag. Less than 18. Comma. Count. One greater than 7. Okay. Tag count inserted counts dot item dictionary, because that's why we need item, and key equals to lambda x colon minus x last item 1 x 0. Then we need print uh, and t colon greater than 7. Tag is string. Okay. Okay, there was an issue here, so I just fixed that. So let's see. Okay, we got result. So we can see all of B appears 50 times, and the most important H1 9 times. Title appears 3 times. So these are very important tags. Oh, next question. Appearance of tags. Okay, so next we will find name of each unique tags in the list. So we need to find total 32 tags is a list. So we need to just print these two functions, length and unique tags. So let's print these, both of them. So we can see we have unique tag names, and then we have total count is 32. Next, we try to find the depth or root of the tags. So for that, we need to import three more packages. We need a DQ. A DQ is a double queue, which allows insertion and deletion on both ends, rear and front end. Then we have to find the tag depth. So trying to get body tag and first, and then we just go through all the tags and try to find the depth of each tag inside. So what we do is we just pop each root element inside the DQ on left side. It uses the BFS breadth word search so that we can breadth first search is uses a graphical structure, and then we will visualize that in histogram. So let's begin. I already imported the packages and already imported this tag from the BS4 elements. Beautiful shape elements we import tag, and then we have this primary functions tag depth, which requires a root. So let's check what is root, and it returns the depth of the each element. So let's check what is root first, and then we will go through it. So initially we just take this one, just comment on this function. Yes. Okay, so let's check what is root first. So for the root first, we need root equals to soup dot body, or maybe you can call it soup. So let's check root first. So we have all the tags and HTML structure inside, and this root or body tag. So next we need to define this function. First we need to use a queue, DQ, DQ, and within DQ we need two elements. First of all, we need this could be empty dictionary. So we need root, and then on the root side we need initialize DQ with the 0. Okay, so let's check. And then we have while loop. While q is true, node comma d equals to pop it on the left side, the d and the node. So node replaces the root and d replaces the 0, and it will pop it. If is instance, if is instance node comma tag that we imported earlier, then q depth dot append d. If there is a node and there's a tag, then it will definitely going to append in the depth list. So then we for C in C is a child node dot children. Yes. If again the same is statement, we can copy this one. Then q.append c d plus 1 and returns the depth. Let's check the depth. Mhm. Yes, one minor mistake. There was like a depth here, so we have emptied its depth. So let's check this depth now. So we can see 0 is the body, and then we have all the ways different tags pops inside. So let's visualize the depths. Okay, so let's visualize the tag depth now. So we have a basic commands for the matplotlib, plt.figure, we need figure size, and plt.title, plt.label, plt.ylabel, xlabel, and plt.show. So let's fill these information. So we need 10 by 6, 10 by 4, and plt.title is, we need to provide what is this title about. We can say DOM, depth, distribution, and X level, Y level. So we can say depth and X level, number of ticks. And plt dot tight layout. So this shrinks there. So important component dot plt dot histo. So we need to show it as a histogram. I already told you. So we need first item depth. First element bins equals to range function from 0 to max depth. Yeah. Plus 2, comma, align equals to left. And then we have this R width equals to 0.9. So yeah, everything is fine. So range bins depth, and we got one typo here, so need to give a comma here. So let's run this one. So now we got this histogram that shows number of tags and how many take each from the body, from body towards and DOM depth distribution. Okay. Next, we have this visualize each tag by count. So we have basic elements for the matplotlib, plt.figure, and figure size we choose 10 by 5, and plt.title, top HTML tags by count. On X label, we have tag, on Y label, on Y side, we have count, and plt.title layout and plt.show. So what we need variables. So let's define So we have tags we already saw from the previous program that we have this both of them. So we need soup and counter, and so we just copy this one here, and we can say top 15 equals to counts dot most common 15. So let's check top 15 tags. Yeah, we have div, anchor, section, and everything here. So now let's visualize these top 15 in this bar chart. So we need to now, okay, so we need labels equals to a new one, values we need two values, and labels equals to zip and from all top 15. So then we have this figure size, and now we need to define plt.bar levels, comma, values. And one thing we need here, so let's first check we have labels and everything now, but we need one more important thing before going here. Now we need this plt.xticks rotation equals to 45, comma, HA equals to right. It's not rotations, but rotation. Okay, so you can see all those important tags by count. Top HTML tags by count. We have count on X label, and now we just need to find a link inside the web page. And finding the link and then converting the relative links to absolute path links. So there are two types of the links inside the web page. One is called relative and other is called absolute. So relative is like a shortcut, short form where you need to click inside, but making it absolute, we need to provide all the protocols, all the detailed HTTP and path and query part of the link. So let's dive into soup part first. So first we need to import URL join and parser, and let's check. So we have this base equals to URL. Let's check the base. So we know that our base is bbc.com. Then we need soup dot select. We need to select A is anchor. So we got all the anchors, numbers, and everything. So within the anchors, we need to go through href. So let's check. So now we got all the href numbers here. So we can say that relative links equals to a href, making it href for a in subset. Okay, let's check relative links now. Yeah, we got all the relative links. You can see video, news, topics, but we cannot click them. So we got links, but we don't have any base. So we have a base already. So we have to join our merge base plus relative links to make them absolute links. So we can say abs absolute links equals to the links that we got already. We can say h for h in relative links. Okay, but what h? URL join. We need to join this one h base comma h. We need to join this one, and let's check this absolute links now. Yeah, we got all those absolute links. Let's count them. So we can say print length these and two of them. Yeah, we got 238 absolute link inside the web page. So 238. It's a DOM tree visualization of HTML tags. So what we do is first we convert HTML document to DOM tree and create a DOM structure. What is DOM tree? A DOM tree is document object model, which provides you the parent and child relationship where you can easily access the child nodes using structure of the DOM. Second, we use the DOM subtrees function, creates a subtree with a maximum number of nodes for the visualization. So we provide how many nodes we require. Our root is like a body. We start HTML from the body. So our root is like body tag, and we then provide how many tags maximum we require. Then we use matplot to plot nodes and edges for the subtree. Finally, the visualization using matplotlib is displayed to show the structure of DOM tree. So let's begin the code. So first of all, we need um, root. Root, we know that we have this from the previous code, soup.body or soup. And then we created one function called DOM subtree that requires root. Maximum node we provide initially 300, and we have two list nodes, edges, and we initialize a stack with a root on 0 position and 0, and none is because body has no parent, root tag has no parent. That's why we put on a stack none value. So let's begin now with the code file. We can say stack and length nodes less than maximum node, max nodes, node comma depth parent equals to stack dot we new knows pop We have two operations, push and pop. If not is instance, if it is not instance of node and take, then continue. So take and continue. Otherwise, idx equals the length. Continue and don't do anything. Node dot append. What we need here, I will show you. If parent is not none, then what you do, dot append parent comma idx. Okay, so four things in nodes dot append: idx, name, depth, and parent. So let's put all of these here. So we can say idx comma, we can say name, node dot name. Here we need depth, and finally we need parent. Okay. Next we have this children. See in node dot children if is instance of what? See and take. See H in reverse children we can say is take dot append. What we need to append is ch comma depth plus 1 comma idx. Three things. So text requires three things and it returns. So let's run this code. Okay, we fixed those issues. Let's check the code again. Line by line, we just initialize stack with a root and zero values as first value, because root is like a parent and it has no other parent. Then it has siblings, like then we just start with the length of nodes, and then we just append node and edges with the different leaves. So we return this node and edges. Let's check what we got in the nodes. So in the nodes, we have idx 0 to all through 300 number of maximum nodes. We provide 250. Yes. So each node, for example, name is body, depth is 0, parent is none. Div depth is 1, parent is 0. Same way, all of those takes. Then we have edges. So from one node to another node, how many edges are there? So from 0 to 1, 1 to 2, and so on. Bit complex, but we need to find them. Okay, and so now let's visualize the DOM tree now. So we got X and Y. X is like length nodes and Y we have depth of those nodes. So plt.figure is fig size is 12 and 6. Then we go through the loop U and V variables with the edges and plt.plot X and UV. On X-axis, what edges we have, and UV we would put there. Then plot.scattered X and Y S equals to 10. Same. So let's check how this tree looks like and refresh this one. And yeah, you can see the DOM tree of this HTML structure. So we have a body div, and div within a div we have a nav and other tag components. So we can analyze different tags of the HTML using DOM tree with this code. So we already wrote this code, and now we visualize using matplotlib. So you can read the code by yourself because we don't have a time left. We have to finish last function now. So next we will extract important information like title, meta description from HTML documents, robot tags, uh, canonical URL, and count the open graph and Twitter card tags like using beautiful library. So we need title, meta, canonical, URL, and OG. So what are these? Let's dive into each of them. So the canonical URL specifies the preferred page version. The robot tag tells search engine what to crawl and index. Open graph tags format content for social media sharing, and Twitter card tags do the same for the Twitter. So let's begin first from the title soup dot title. So we can say title. So we have a title, but let's check this if it is a string. So we need to make it a string, or is it empty? So if we are providing or, then it should be like this one. So let's check. No, title is not empty. So need to strip also the spaces. And if soup dot title, if it is, then otherwise else it is empty. So we can have this title first. Next we have this meta equals to, okay, so we need m.get, m.get, m.get dot lower. So what we need in m.get is name first. Name in double quotation, then we need property. And then we need content m.get. So we need to loop through for m in soup dot find underscore all. What we need to find is a meta. If m.get content then to this one. Okay, so let's check meta. Yeah, one wrong. We closed the bracket. Yeah, we got meta, we got title. So description of the complete page. This is a very important information for a web page. So we are reading the meta tag information. Soup dot find linked relation equals to lambda and say okay, canonical in v dot lower. Let's check this canonical tag. So we have href relationship is bbc.com. Finally, we need to check OG equals to and then for m in soup dot select meta property equals to OG dot double quotation mark missing here. So we have the OG description, visit BBC for trusted reporting on latest world news support. So we have OG information now. And finally, pin graph tags. Now we have TW Twitter tag. So TW Twitter tag, we can say that I have just copied this code to save the time. So we can have a Twitter tag BBC, Twitter description, visit BBC. So these are very important points that we need to consider. So let me print all this important information in a better way so we can get a meta.get description, meta.get robots, canonical, length, OG, length TW. So we have all this important information in Lost. Conclude this web summarizer part 1 video. Theoretical chapters, please cover web mining course detail.